A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, we are diving into a big one today. Daniel's prompt is about the actual literal plumbing of AI safety. We are talking about guardrails. And I don't mean the vague concept of being ethical. I mean the specific libraries, the proxy layers, and the architectural decisions that keep an LLM from emptying a bank account or leaking a CEO's home address.
This is such a critical shift in the industry, Corn. We've moved past the era where safety just meant the model wouldn't write a mean poem. Now that we have agents actually executing code and moving money, guardrails are essentially the new enterprise firewall. By the way, a quick shout out to our silent partner today. This episode's script is being powered by Google Gemini 3 Flash. Herman Poppleberry here, ready to get into the weeds.
Poppleberry in the house. So, Herman, let's start with the where. If I'm building an app, where does a guardrail actually live? Is it inside the model? Is it a separate server? Because I feel like people talk about safe models and guardrails as if they're the same thing, but they really aren't.
They are fundamentally different levels of the stack. Think of training time alignment, things like reinforcement learning from human feedback, or Anthropic's constitutional AI as the model's upbringing. It's baked into the weights. It's the model's internal compass. But as we've seen with every jailbreak on the internet, internal compasses can be spun around with a clever DN prompt or a weirdly formatted base, 64 string.
Right. The ignore all previous instructions trick. It's hard to hard code a personality that can't be tricked.
Well, not exactly, but you're on the right track. This is why we use inference time guardrails. These sit in the call chain. Imagine a user sends a prompt. Before it ever touches the LLM, it hits an input guardrail. This is a middleware layer that checks for prompt injection, PII, that's personally identifiable information or banned topics. If it passes, it goes to the LLM. Then the LLM generates a response, but before the user sees it, that response hits an output guardrail. This checks if the model hallucinated, if it's leaking secrets, or if it suddenly started talking about a competitor's product.
So it's a sandwich. The LLM is the meat, and the guardrails are the bread keeping everything from falling into your lap. But that bread isn't free, right? Every time you add a layer of checking, you're adding latency. If I'm a user, and I have to wait an extra 3 seconds for a safety check to run on a separate model, I'm going to lose my mind.
That is the #1 tension in production right now. The latency cost is real. If you're using a simple regex filter or a keyword list, you're looking at maybe 10 milliseconds. No big deal. But the industry is moving toward LLM as a judge. That's where you use a smaller, faster model like Meta's Llama 3.8b or a distilled specialized model to look at the input and say, is this a jailbreak? That can add anywhere from 200 milliseconds to over a second depending on the hardware.
A full second? In the world of real-time chat, that's an eternity. That's the difference between a snappy assistant and a loading spinner that makes me want to close the tab. How does that work in practice for something like a customer service bot? If the user asks, "Where is my package?" does it really need to spend a second checking if that's a cyber attack?
It shouldn't, and that's where the architectural nuance comes in. You don't run the heavy-duty checks on every single interaction. You use a dual-rail approach. It's about being smart with the fast path versus the slow path. For common stuff obvious swear words, known injection strings, or basic formatting, you use deterministic code or tiny specialized classifiers. Those are lightning fast. You only trigger the slow path, the heavy LLM-based reasoning, when the intent is ambiguous or the risk profile changes. It's a tiered defense.
Okay, let's get into the actual tools. If I'm a developer and I want to build this today, I'm looking at the open source world first. I keep hearing about NVIDIA NeMo guardrails. What's the weird thing about NeMo? Because NVIDIA doesn't usually do high-level Python libraries for fun.
NeMo is actually really fascinating because of Golang. It's a specialized modeling language they developed just for conversation flows. Instead of writing a million if-else statements in Python, you define flows. You can say, if the user asks about politics, steer them back to our product catalog. It treats the LLM as a programmable state machine. It's very powerful for topic railroading, ensuring the bot doesn't end up in a rabbit hole about conspiracy theories when it's supposed to be selling shoes.
Topic railroading. Sounds like something a grumpy conductor does, but I get it. You're narrowing the latent space the model is allowed to play in. But wait, if I use Golang to define these flows, am I essentially turning the AI back into a chatbot from 2015? Those if this, then that bots were terrible.
Not quite, because the if statements in Golang are still backed by semantic embeddings. It's not looking for exact keywords, it's looking for the intent of the sentence. If the user asks about the current election or who I should vote for, the embedding model recognizes both as political intent and triggers the rail. It's the flexibility of an LLM with the deterministic control of a script.
Got it. So it's a flexible leash. What about the one simply called Guardrails AI? I see that Python library everywhere on GitHub.
Guardrails AI is the darling of the structured data crowd. Their big thing is Rail. Reliable AI markup language. Look, the biggest headache with LLMs in production is that they are probabilistic. You ask for JSON, and 99% of the time it's fine, but that 1% where it forgets a closing bracket or adds a conversational, here is your JSON, prefix breaks your entire backend.
Oh, I've lived that nightmare. You write a beautiful parser, and the LLM decides to be helpful by adding a preamble like, certainly, I'd be happy to format that data for you.
Guardrails AI fixes that. It wraps the LLM call and enforces a schema. If the LLM misses the mark, the library can actually trigger a re-ask. It sends the error back to the model and says, hey, you messed up the formatting, try again. It's about making the model's output type safe, which is a huge deal for enterprise reliability.
It's basically a bouncer that says, you're not coming in unless you're wearing a suit and tie, and that tie better be a valid JSON object. Now, you mentioned Microsoft Guidance and LMQL earlier. Those feel different. They aren't just checkers, right? They're more like steering wheels?
That's a perfect way to put it. Guidance and LMQL, which stands for Language Model Query Language, are prompt programming languages. Instead of sending a prompt and praying, you actually interleave your code with the LLM's generation. You can force the model to choose from a specific list of tokens at a specific point in the sentence. It's token-level control. If you know the next word must be yes or no, you literally don't let the model even consider any other tokens. It's the ultimate guardrail because it's impossible for the model to drift off topic if the program logic is holding its hand token by token.
That seems way more efficient than waiting for a full response and then checking it. You're preventing the crime before it happens. But I imagine that requires a much tighter integration with the inference engine. You can't really do that over a basic API call to OpenAI as easily as you can with a local model.
You hit the nail on the head. That's why those tools are huge in the open source self-hosted community. If you're running Llama 3 on your own hardware, guidance is incredible. If you're just hitting the GPT-4o endpoint, you're more limited to those sandwich-style guardrails we talked about. Speaking of Llama, we have to talk about Llama Guard.
Is that just llama with a badge and a gun?
Pretty much. It's a version of Llama that Meta fine-tuned specifically to be a safety classifier. It's trained on 13 specific categories of bad stuff: violence, hate speech, sexual content, criminal advice. Because it's a standardized model, it's become the industry benchmark for LLM as a judge. If you want to know if a prompt is safe, you run it through Llama Guard 3 first. It's fast, it's open, and it works surprisingly well.
It's the safety officer model. I like the idea of a tiny, specialized model whose only job in life is to be a buzzkill. It's efficient, but what happens if Llama Guard is too strict? Like, if I'm building a tool for a novelist writing a thriller, and the model flags a description of a fictional crime as violence.
That's the over-refusal problem. It's a huge issue. If a safety model is too aggressive, it makes the product useless. This is why many developers use soft guardrails. Instead of a hard block, LlamaGuard might return a safety score from 0 to 1. If the score is 0.8, you might block it. If it's 0.4, you might just append a warning or log it for manual review. It's about tuning the sensitivity to the specific use case.
So it's a dimmer switch, not a light switch. Now, what about the corporate side of things? If I'm a bank, I'm probably not just stitching together a bunch of GitHub repos and hoping for the best. I want a dashboard. I want someone to sue if it fails. Who are the big players in commercial guardrails?
The commercial landscape is exploding because of day 2 operations. It's one thing to build a guardrail, it's another to monitor it, audit it, and update it across 10,000 employees. You mentioned Arthur AI and Robust Intelligence. Robust Intelligence was actually just acquired by Cisco, which tells you everything you need to know about where this is going. It's becoming a networking and security problem.
Cisco buying an AI safety company is such a nature is healing moment for the tech industry. It reminds me of the early days of web security when everyone realized you couldn't just trust the browser. Back to the hardware and the wires. What does a robust intelligence or a Lakera actually give you that a Python library doesn't?
Performance and threat intelligence. Take Lakera, for example. They have Lakera Guard. It's an ultra-low latency API specifically for prompt injection and jailbreaking. They are constantly updating their threat signatures based on the latest jailbreaks found in the wild. If a new grandma exploit, where you tell the AI to act like your grandma who used to read you napalm recipes, starts trending on Reddit, Lakera updates their filters instantly. You're paying for the up-to-the-minute protection.
I love the grandma exploit. It's so wholesome and terrifying. Now, dearie, to make the napalm, first you take some gasoline. It's wild that a security system has to understand the concept of a persona to stop a hack. So, Lakera is like the CrowdStrike of AI. They're looking for the malware, which in this case is just a weirdly phrased sentence. What about the governance side? I've heard Patronus AI and Calypso AI mentioned in the same breath as risk management.
Those are more about the human in the loop and the evaluation side. Patronus is really interesting because they focus on automated evaluation. They help companies score their models. If you're an insurance company, you need to know, how often does our bot accidentally give legal advice? Patronus runs thousands of adversarial tests, essentially attacking your own model to give you a hallucination score or a PII leak score. It's about quantifying the risk so the legal department can sleep at night.
And Calypso?
Calypso AI is very focused on the control plane. They provide a dashboard for security teams to see every single prompt entering or leaving the organization. It's about observability. If an employee tries to paste sensitive source code into a public LLM like ChatGPT, Calypso catches it, masks the PII, and logs the incident. It's DLP, data loss prevention for the AI age.
It's funny we spent decades trying to stop people from putting files on thumb drives, and now the thumb drive is just a text box that talks back to you. It's a much harder problem to solve. You can't just block a USB port. You have to block a thought process.
It's infinitely harder because language is fuzzy. You can't just block the word password. Someone could ask the model to describe the string of characters I used to log in, but do it in the style of a pirate. A traditional firewall sees pirate and says, A-OK. An AI guardrail has to understand this intent of the pirate.
Me secret is hunted too. Yeah, that's a problem. So, Herman, if you're a CTO today, how do you choose? Do you go with the build route using NeMo and LlamaGuard, or the buy route with something like Arthur Shield or Lakera? What's winning in the real world right now?
It's a defense in depth strategy. Nobody is picking just one. The winning stack I'm seeing in production usually looks like this. You use something like LlamaGuard for general safety because it's cheap and fast. You use Guardrails AI or Guidance for your core application logic to ensure the data stays structured. And then you layer a commercial tool like Lakera or Robust Intelligence on the very front end to catch the really sophisticated zero-day prompt injections.
So it's a series of filters. The big rocks get caught by the simple stuff, and the fine sand gets caught by the expensive stuff. But I have to ask, what about the model providers themselves? OpenAI, Google, Anthropic. They all have safety settings you can toggle. Why would I pay for a third-party tool if Google Vertex AI has a safety filter slider? I can just move to high.
The problem with the built-in filters is that they are black boxes. They are all or nothing. If Google's filter decides a prompt is unsafe, it just returns a generic error. As a developer, you have no idea why it was blocked. Was it a false positive? Was it a specific word? You can't tune it for your specific business logic.
Right. If I'm a medical app, I needs the model to talk about symptoms and body parts. A standard safety filter might see those words and panic, thinking it's explicit content. Or if I'm a cybersecurity firm, I need my model to analyze malware code without the safety filter thinking I'm trying to hack a hospital.
A bank can't use a safety filter that blocks the word debt or bankruptcy. Third-party guardrails allow you to define your own allowed and disallowed spaces. They give you the why. They provide audit logs that you can show to a regulator. The cloud-native filters are a great step 0, but they aren't a step 10 for a regulated industry.
It feels like we are seeing the professionalization of the vibes. We started with, does this feel safe? And now we have Golang, state machines, and Rail markup languages. It's becoming a real engineering discipline. I wonder, does this lead to a sort of guardrail arms race? Like, as the bouncers get smarter, do the jailbreakers just get weirder?
Oh, absolutely. We're already seeing adversarial suffixes. These are strings of seemingly random characters that, when added to a prompt, bypass the safety training of the model. The guardrail companies are in a constant race to detect these patterns. It's no different than the antivirus companies of the 90s chasing polymorphic viruses. It's a cat and mouse game that will likely never end.
Interesting. So the guardrail is the antivirus for the LLM. I suppose that means we'll eventually have guardrail bloat, where the safety layers are so heavy the AI can barely move.
That's the risk. Because the stakes are moving from the bot said something embarrassing to the bot just executed a $10,000 wire transfer because of a prompt injection. There's a notable quote I saw recently that really captures this shift. In 2024, guardrails were about stopping the AI from saying something offensive. In 2026, which is where we are now, guardrails are about ensuring the AI doesn't accidentally tank the company's balance sheet.
It's the move from safety to security. One is about feelings, the other is about assets. I suspect we're going to see a lot more safety engineers who are actually just cybersecurity pros who learned how to talk to LLMs.
That's the new collar job of the decade. And what's interesting is the small model trend. Instead of using a massive model like GPT-4 to check another model, companies are training these distilled safety models. Tiny 1 billion or 3 billion parameter models that run on the same server as your app. It cuts the latency down to almost nothing while keeping the reasoning power of an LLM.
It's like having a very small, very focused dog that only barks when it sees a specific type of intruder. It doesn't need to know how to solve calculus. It just needs to know stranger danger.
That's the future. Local, hyper-specialized guardrails. It's the only way to scale this without making every AI interaction feel like you're waiting for a dial-up modem to connect. Imagine a world where every API call has a safety sidecar, a tiny container running a 1B model that validates every token in real time.
All right, let's talk practical takeaways for a second. If someone is listening to this and they've got a wrapper app that's basically just a prompt and a text box, and they want to harden it, where do they start?
Step 1. Use a structured output library. If you aren't using something like Guardrails AI or Pedantic with Instructor, you're asking for trouble. Just getting your data into a reliable format solves half your safety problems because it prevents the model from hallucinating weird stuff into your UI. It forces the model to stay within the lines.
Step 2. Add an injection detector, even a simple one.
Yeah, look at the open source prompt injection datasets on Hugging Face. Run a small classifier. It's cheap insurance. And step 3, if you're in a regulated field, start looking at the eval tools like Patronus or Arthur Bench. You can't fix what you can't measure. You need to know your failure rate before a customer finds it for you. If you don't know that your bot fails 2% of the time when asked about medical advice, you're flying blind.
You can't fix what you can't measure. You've been reading those management books again, haven't you?
Guilty as charged. But in this case, the measurement is the difference between a successful product launch and a front-page headline about an AI gone rogue. Think about the Air Canada chatbot case from a few years back where the bot promised a refund that didn't exist. A simple output guardrail checking against the official refund policy database would have caught that before the customer ever saw it.
Right. The bot was hallucinating. A generous policy because it wanted to be helpful. The guardrail would have been the skeptical supervisor saying, "Wait, check the handbook first. I think the dual rail architecture is the big aha moment for me here. The idea that you don't have to choose between safe and slow or fast and risky. You can have both if you're clever about the routing."
It's all about the routing, and we're seeing that in the AI control plane too. Tools that manage these guardrails across multiple models, because most companies aren't just using one LLM anymore. They've got Claude for writing, Gemini for long context analysis, and Llama for internal tasks. You need a guardrail that works across all of them, a unified safety policy.
One ring to rule them all, but instead of a ring, it's a middleware proxy with a very strict set of rules.
Spoken like a true sloth.
Hey, I'm just here to make sure we don't move too fast and break the world. Someone has to be the voice of, "Let's check the JSON formatting one more time."
And that's why we make a good team. This is a deep topic, and we've barely scratched the surface of things like adaptive guardrails that change based on user reputation, where a trusted power user gets a lighter touch than a brand new anonymous account. But for a State of the Union in 2026, I think we've covered the heavy hitters.
Agreed. If you're building in this space, the Wild West days are over. The bouncers have arrived, they've got clipboards, and they're surprisingly good at their jobs. It's no longer just about the prompt, it's about the entire pipeline.
They are, and they're getting faster every day. The goal is invisible safety, where the user never feels the guardrail, but the developer never feels the anxiety.
Well, that's our deep dive into the world of AI guardrails. It's a lot of plumbing, but it's the plumbing that's going to allow AI to actually do real work in the world. Big thanks to Daniel for the prompt. This was a fun one to research.
Definitely. It's one of those topics that sounds dry until you realize it's the only thing standing between us and a very weird, very buggy future.
A very weird, very buggy future. That should be the title of your autobiography, Herman.
I'll put it on the list right under How to Talk to Sloths.
Thanks as always to our producer, Hilbert Frumingtop, for keeping the gears turning behind the scenes. And a huge thanks to Modal for providing the GPU credits that power the generation of this show. Without those H100s, we'd just be two animals shouting into the void.
And nobody wants that. If you found this useful, do us a favor. Leave a review on Apple Podcasts or Spotify. It actually makes a huge difference in helping other AI-curious folks find the show.
This has been My Weird Prompts. You can find all our past episodes and the RSS feed at myweirdprompts.com.
Stay safe out there.
And keep your JSON valid. See ya.
Bye.
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow to